Hey, fifth grade, we're going to work through workbook page 170 today, and this will be your only workbook lesson and work for virtual learning. The rest is going to be your snow packet. So this is a very easy 10-point earning here. It's like 5 or 6 questions on this page, and that's it. So make sure you do this and do it well. You are even allowed, if you would love to pause the video here and practice this whole page on your own and then run the video and see how you did. That's an okay thing to do. So whatever you feel most comfortable with, you do that and you'll be just fine. Okay. Alrighty. Use the properties of addition to find the sum. So we know that even though these are in parentheses, we can actually, since we're adding all 3 of these fractions and mixed numbers, we can actually just look at our common denominators, which here are eighths, right? So let's do 1 and 1/8 plus 1 and 5/8, and together we have 1 and 6/8. Now, oopsie, some of you immediately notice, like, hey, 1 and 6/8 is really 1 and 3/4. Yes, it is. So you can leave it as 1 and 6/8, or you can simplify it to 1 and 3/4, but we still do have to add that 4 and 2/3. Okay. And with 4 and 3, I'm going to make 12 my common denominator. So 4 times 3, 3 times 4. Okay. And sorry, I'm out of room here. I'm going to rewrite it. Some of you think you can skip that step. It is not a very skippable step. Okay. 1 plus 4. Oopsie. Nope. I'm ahead of myself. Woof. I almost skipped the step. Okay. So we've got 1 and 9/12 plus, let's see here, 4. I'm just trying to make sure my mixed numbers are big. Okay, so just be careful because if you plug it in, excuse me, in a small way, it looks like part of the numerator and it's not. So we just be aware of that, okay? 4 and 8/12. Now that equals 5 whole. 9 plus 8 is 17 over 12. We've got an improper fraction here. So I'm going to take away 1 whole, take away 12 out of 12, or some of you prefer to do 17 divided by 12, and that's fine. Just make sure you understand 17 over 12 is the 1 whole and 5/12 that you get as an answer when you divide, and you add that 1 and 5/12 to the 5. Okay, so here I'm taking away a whole, I'm going to add it to the 5. I end up with 6 whole, excuse me, and 5/12. Okay, so that is my answer all the way back on number 14. Sorry about that. You know how we really love to use up paper and show my work. So this goes way back there. If you want to put this stuff in your notes to have examples, I highly recommend that because we have a test coming up before you know it. You can do that in your notes and then just plunk your answers here, do some basic steps. All right. Number 15. Okay, I have 18ths here and here. Let's put those together immediately. 4 and 10/18. And again, some of you immediately recognize this as being able to be simplified, right? And I mean, it doesn't matter to me. I did it last time, so I'm going to skip that part this time. If you want to do it, go for it. We still have to add 3/4. Okay. 18 and 4, that immediately that kind of scares me as a denominator, just because I'm not as familiar with 18, right? So if you think about 4 doesn't go into 18, like, oh dear, slight panic moment. But if you double 18, you get 36, right? And 4 goes into 36. So let's go with that. Let's double the 18, double the numerator. Okay, and then 4 times 9 gives me 36. 3 times 9 gives me 36. Rewrite it. So 4 and 20, 36 plus 27 36 equals 4 whole, and 47 out of 36. Okay, and again, a lot of you like to just subtract 1 whole, tack it on to the whole number. That's totally fine. I'm going to do it differently just because I know some of you prefer that, and that's okay. Either way is good. 47 divided by 36. Oh boy, 36 goes into 47 once. Take away 36. And it looks like we have 11 left. So 1 and 11 out of 36. So I'm not adding that onto this. This actually equals this improper fraction. Those are the same thing, okay? So now I converted it from improper to mixed number, and I still have the 4 out in front plus, plus the 1 and 11 36. So the answer for number 15 is 5 whole and 11 out of 36. Okay, and that answer goes over here. All right, number 16. If you haven't yet, I would encourage you to pause the video, try this on your own, and then just see how it's going, okay? This is silly. I'm actually going to start over here with this just because you know my spacing gets all sorts of bonkers, but we have 7/10 and 1 and 1/10, so put it all together, 1 whole and 8/10. And again, many of you notice this and you're like, hey, that's really 1 4/5. Yes, it is. Okay. A lot of times when you simplify these fractions, it's easier for you to add the next thing. Okay. Not always, but a big chunk of the time, I would say. Now, the beauty of this is 5 goes into 15. Okay. If you leave it as 15 and 10, you would need a common denominator of 30, which isn't bad, but you can leave it as 15 and just take this times 3. I'm going to switch to the text here because times 3, rewrite it. So this equals, oh no, I skipped again, sorry, 1 whole and 12/15 plus 2 whole and 4/15 equals, we have 3 whole and 16/15. A lot of you are getting so good at this that you immediately can simplify your improper fraction, add it to your mixed number, convert it all, and make it beautiful. And just in case it's still a little scary, that's okay. Take away 1 whole here or divide and add it on, right? Add on that whole number. We have 4 whole and 1/15. And that's the answer to number 16. Number 17, Valerie writes the expression 1/12 plus 4/5 plus 1/5 plus 7/12. How can she use the properties of addition to rewrite the expression so it's easier to add? Okay, you know the drill here. She can immediately add the like denominators or the common denominators, right? And if we want to push that together, so we can do 4/5 plus 1/5. Add those together, then add 1/12 plus 7/12 and do all the adding and converting and all of that. Number 18, the table shows the portion of 3 different types of pizzas that Nimal and Peter eat at a team party. All of the pizzas are the same size, and that makes a difference because if you have a personal pizza, that is not the same as a delicious large Casey's pizza, right? Okay, who eats more pizza, Nimal or Peter? Okay, when I'm glancing here, let's see. So let's combine Nimal's like denominators. So 1/8 plus 3/8 is 4/8 or half of the pizza. And we're still going to add add 1/6. Okay, I believe 24 is our least common multiple here. So 3 groups of 8. Convert the numerator, 4 groups of 6, and same with the numerator there, right? And then the good old rewriting it. Here we have 12/24, same as 1/2, plus 4/24. And this ends up being, sorry, my things are not really in line, but you'll just write it really, really neat. So we've got 16/24. And those are even, so I know I can reduce them. Actually, I can divide both of these by 4. So divided by 4, that's 4. Divided by 4, that's 6. Oh my goodness. We could have just divided them by 8. 4 and 6 are even, so divide by 2, that's 2. Divide by 2, that's 3. So Namal has eaten 1/3 of a pizza. Oh, 2/3. Whoopsie. I was like, why? That's less than half. That doesn't make sense. 2/3. All right. Peter will add the 1/4 and the 1/4 together. That's 2/4, which is the same as 1/2. But if you want to leave it as 2/4, that's okay. Plus another 12. So here we're going to use 12 as our denominator times 6 times 6. And we end up with 6/12 or 1/2 plus another 1/12. Which equals 7/12. Okay, now we're not really done yet, right? So Peter has eaten 7/12 of a pizza. So we've got to figure out, like, okay, different ways to do this now. I'm gonna clear this. So we've got 2/3 for Namal. And oops, 7/12. Okay, 2/3. I had to double check. 7/12. Now, both of these are over 1/2, right? Quick visual. These are not always accurate, so just be careful. Here's 1 2/3, 7/12. 6/12 is 1/2. And let's see, those would be 4ths, 8ths, about like this. Okay, that is not very neat. I'm so sorry. So Namal eats more pizza than Peter. How much more pizza does this boy eat than the other one? Oh, okay, so now they want the difference. So Namal, we've got 2/3. We're comparing it. How much more does he eat than the other guy? Take away 7/12. Here times 4 here to make this out of 12ths as well. So we have 8/12, and we're taking away 7/12. We have 1/12 left of the pizza, or difference, sorry. 1/12 more pizza. Okay, last one. Find the sum without using the properties of addition. Oh man, they're a little bit rough here. So of course I immediately want to group those two together with the 9ths, but they're telling us not to. So let's make a common denominator. 36. So we have to do times 4 to the numerator times 4 to the denominator. And then here times 9 numerator and denominator. Make 36 our common denominator, right? And this one times 4 times 4. Okay, and the good old rewriting. So this is 2 and 4/36. I'm really trying to keep it neat for you guys. So give it a go. Plus 3 and 27/36. Plus 3 and oops, and 28/36. All right, now put all of your whole numbers together. 3, 6, 7, 8. You get 8, and I'm guessing it's going to be improper here. Ooh, that's really hard to read. Sorry, 5th grade. 3 and 28/26. All right, so we've got 27 plus 4, which is 31, plus another 28, which is 59. Oh boy. 59/36. Obviously, we can tell that's improper. So whether you want to divide it out or subtract, it ends up being the same step, just in a different way. So take away 36 out of 36, add that whole to the 8. We get 9. And then 59 minus 36 is 23, and it's still out of 36. I don't believe we can reduce it at all. So that should be it. Would it have been easier to use the properties of addition to reorder and regroup the add-ins? Oopsie, oh golly, I kind of disregarded the parentheses. I was on such a roll. So we should have added this together and gotten 5, 31, 36, and then kept going. We still would have got there. Would it have been easier? Of course it would have been easier. It would have been so much nicer for our brains, but alas, we still got the answer, right? So they just wanted to challenge us there and really show us, hey, this whole grouping thing and using some awesome properties of math to group things to make it easier for your brain is indeed easier for your brain. Good work. Carry on, Mustangs.